Welcoming you all. We are going to deal about the topic of photovoltaic system for power generation. I am Dr. B. Sivasankari, Assistant Professor of Physics, SFR College for Women, Sivagasi. This is the basic photovoltaic system integrated with the utility grid. Okay, what is meant by an utility grid? Utility grid is usually a commercial electric power distribution system that takes electricity from a generator and transmits it over a distance, then takes electricity down to the consumer through a distribution. So, what is the use of a utility grid? It is going to take the electricity from a generator and then transmits it over a distance to the consumer. Okay, so it is going to distribute the electricity to the consumer. Okay, that we say it as utility grid. Okay, then in this diagram, if you see, means solar cell array. First component is solar cell array. Solar cell array means an array of solar cells, and then a battery storage. The energy is going to be stored in the battery, then a converter, then a local load. Okay, solar cell, first component solar cell, if I say, it means and is an array of solar cells. If you see, means in between the solar cell array and the battery storage, there is an arrow with a line, isn't it? That we say it as a diode. What is the use of a diode? Means it will allow the flow of current in only one direction. Okay, so here, whenever the solar cells are irradiated with the sun's radiation, the energy is going to flow into the battery. There is no reverse flow of energy from the battery to the solar cells. The energy should flow only into the load. Now, what is a load? The power consumption devices, what and all we are using the household, we say it as load. Okay, so the stored energy from the sun's radiation, it should be delivered only to the load, and there should not be any reverse flow. So it is done by means of this diode. Okay, this diode we say it as blocking diode. Then if you see, the next component means converter. So here, the converter mainly we are using is the inverters. Inverters are the devices usually solid state. So inverters are nothing but the solid state devices which change the array DC output to AC of suitable voltage, frequency and phase to lead photovoltaically generated power into the power grid. So the inverters are going to convert the DC output to the AC. So here, from this solar cell array and the battery storage, we are going to have the DC output that can be converted to AC by means of this converter. The converter here mainly we are using is the inverters. Okay, okay, we can go briefly into this block diagram description. Okay, these functional blocks are sometimes referred to as power conditioning. Okay, a basic photovoltaic system consists of solar array, as I already said, no, large or small, which converts the insulation, the sun's radiation, to useful DC electric power. Okay, a blocking diode, then a blocking diode which lets the array generated power flow only towards the battery or grid. I said no, without a blocking diode, the battery would discharge back through the solar during times of insulation. There is no sun's radiations, means there can be chance of battery discharge back into the solar ray, so it should be prevented. So we are using the blocking diode between the solar array and the battery. Okay, the next component is battery storage, in which the solarly generated electrical energy is stored. So we are storing the electrical energy in the battery. The stored energy can then be delivered as electricity upon discharge. They also act as buffer between the solar array and the load. The battery supplies energy to the load during periods of little or no solar irradiance and stores energy from the array during periods of high irradiance. So the battery, what is the use of this battery? Means it is going to store the energy during periods of high solar radiations, and it is going to deliver the stored energy to the load during periods of no solar irradiance. Okay, this enables the system to meet momentary peak power demands and to maintain stable voltage to the load. Okay, then we are going to see the advantages and disadvantages of PV systems. First advantage, if you see, means direct room temperature. So at room temperature itself there is a conversion of light to electricity through a simple solid state device. So what is a simple solid state device? Here the simple solid state device is a semiconductor device. So direct conversion of light to electricity. Then here there is no moving parts. Then the third point, if you see, means ability to function as unattended for long periods. There is no repair. The component is having some repair problem as like that, there is no need to say, okay, that there will be no problem like that. So that is one main advantage. Then modular nature, in which desired current voltages and power levels can be achieved by more integration. If you want to extract more current voltage and power levels, means we can have PV systems, more PV systems combination, and we can have the desired current voltage and power levels. Then maintenance cost is very low, and then easy to operate, no pollution, then long effective life, they are highly reliable. Then here no fuel is required because the sun's energy, it is free. Okay, then they have rapid response in output to input radiation changes. Whenever the sun's radiation level is changing, then the output is the current voltage and the power level, it is going to change. So there is rapid response in the output to input. Then they have wide power handling capabilities from microwatts to kilowatts or even megawatts. We can extract powers from microwatts to megawatts if you use a combination of array of PV systems. Then they are easy to fabricate. Easy to fabricate means we can easily design these semiconductor devices. Then they have high power to weight ratio. Example, the roof loading on a house top covered with solar cells. So to extract the sun's radiation, if you see, means in some roofs, in the roof of some houses, they are having solar cell arrays. So if you see that weights, means weight of that solar cell arrays, if you see, means the weight is very less compared to the power that we are going to extract. So it is said that they have high power to weight ratio. Okay, then decentralized or dispersed power, what is this means? There is no problem of power distribution by wires, no need of wire connections and all. Directly we are going to get the sun's radiations, and then we are going to distribute. Then they can be used with or without sun tracking. No need to track the sun's position and all. Just we are going to collect the sun's radiation, and then we are going to use it. Okay, so they can be used with or without sun tracking. Then the main disadvantage is its high cost. Then energy storage is required because of no insulation at night. So in during night times, if you see, means the stored energy, it should be retained in the device. There should not be any loss. So it is a main drawback of it. Efforts are being made worldwide to reduce cost through various technological innovations. Then we are going to see the applications of solar PV systems. They are used in water pumping sets, signal fire for ship navigations at ports, community radio TV sets, cathodic protection of oil pipelines, weather monitoring, railway signaling equipment, battery charging, street lighting, etc. Okay, thank you. I hope you have enjoyed this session. Thank you.